Jai Hind everyone, myself Richa. Today we will discuss about the amplitude modulation. It is one of the most important topic in any communication system. So today discuss about what is amplitude modulation. Before amplitude modulation, we will discuss what is the frequency translation and what is the need of this frequency translation. Actually, the process of frequency translation is one in which the original signal is replaced with a new signal, right? So if you have a one signal that can be replaced with a new signal and whose spectral range extend from f1 to f2. f1 is one of the frequency. It means we are transferring our signal from one frequency to another frequency. This is called frequency translation, right? And in which new signals bear, and it is recoverable form and the same information as was born by the original signal. It means if we are having one signal at a particular frequency of f1, by frequency translation method we will shift this same signal at a different frequency that can be called a higher frequency of f2, and the signal will bear the same information which it has original, right? And this signal can be recoverable at the receiver end also. If it is the main property that we require, if we want to modulate anything, that can be recovered by the receiver also. If it is not recoverable at the original shape, then it is a failure of the information transmission. So if we want to transmit anything and at a higher frequency, then it should be recoverable at the receiver end. Then only your communication will be set up, and we can say that is a successful communication if the signal is received by the receiver. So how can this frequency translation can be done? We will study. Before that, we will study what is the need for frequency translation. Why we cannot send the information at a same frequency which we have done. The same frequency means if the signal is at the frequency of f1, so why this signal cannot be transmitted at a frequency of f1? So first need is a frequency multiplication. Frequency multiplication means if we want to transmit number of signal which is lying on the same frequency spectral, then how can we transmit these signal? And we are having only one communication channel, because signal can be transmitted by a channel. Channel is basically a medium through which we are transmitting information from one place to another place. And if there are number of information we want to transmit on a single channel, and all the informations lie on the same spectral range, so what to do? So we can use frequency multiplication. Okay, so frequency multiplication is one of the requirement for frequency translation. So different message bearing signal in different frequency range. By using the frequency translation, what we will do, we will convert the signal frequency to another frequency. So we can say the channel is divided as per the frequency spectrum. One signal will travel at one frequency, another will be travel at another frequency. So simultaneously we can transmit a number of signals on a same channel with different frequency, right? Second is the practicability of the antenna. Actually, if we want to transmit anything or if we want to receive anything, the antenna is the main part which is used to transmit a signal, transmit or receive a signal, right? So main component of your transmission and reception is the antenna. An antenna, anything can be transmitted if its length is comparable with the wavelength of the signal, right? So if you want to transmit a signal of low frequency, then the height of antenna will be very high. So if we want to transmit a signal of kilohertz, then we require a height of kilometer of the antenna. This is not practicable. Okay. So we require that if we want to transmit a signal of low frequency, we will superimpose the signal on a higher frequency, then only we can transmit. If we change the frequency from f1 to f2, f2 is a higher frequency. So if we transmit a signal from f1 to f2, f2 is a higher frequency. So what will happen? We require the length of the antenna will be reduced. So this reduced length will be helpful to make an antenna which is practicable, and we can transmit a signal at a higher frequency, and this signal is recoverable at the receiver end, right? Third requirement of frequency translation is the narrow banding, right? So narrow banding, what is the meaning of the narrow banding? For example, if we want to transmit audio signals, okay, so audio signal is ranging from audio signal is ranging from 50 to 10 to the power 4 hertz, right? Okay. So if we want to transmit this signal, so what is the ratio of maximum to minimum? So if I want to find out the maximum to minimum ratio, it comes out to be 200 basically, right? So this 200, it means the variation between the high frequency and low frequency is around 200. So it means if we want to transmit a signal, so for the low frequency antenna height is very large, but for the high frequency antenna size is small. So it means we require different antenna size for different frequencies, or we can say higher and the lower frequency. So what we can do, we can transmit this signal at a higher frequency. If I will translate this signal at a frequency of 50 into 10 to the power 6, and here it comes out to be, right? It means a complete signal we have transmitted at a frequency of 10 to the power 6, right? So 10 to the power 6. So what will happen? So now the minimum to maximum ratio comes around 1.01. Okay. So it means the height of the antenna for the lower frequency as well as the higher frequency remain the same. Next is the common processing. For shifting of signal to a common frequency range to use same processing block, it means sometime what will happen, we want to transmit a signal and this signal is operated at a different frequency and we have the system which is operating at a different frequency. Okay. So if we want, either it will be possible to make a system at all the time which will support your frequency, or you will convert your frequency at the level which is supported by the system. Okay. So if we want, if we are having some systems and if we want to transmit a signal, we will convert the signal into the frequency which is supported by the available system. So this is the main how we can use a different frequency signal at a common processing system, right? So these are the 4 basic requirements why we are going towards the frequency translation. So what is the need to transmit a signal at a higher frequency? And in layman language, if we want to say, it means the frequency translation is basically an idea to convert your low frequency signal into high frequency signal. And how it can be done? Your low frequency signal will be superimposed in a higher frequency signal, and this higher frequency signal is basically carrier. It will carry your signal from one place to another. If I will take an normal example, for example, I want to go from Delhi to Meerut, right? One way is I will walk from Delhi to Meerut. It will be very difficult to walk from Delhi to Meerut. Okay, it means I can say this is the low frequency, and if we do the modulation, it means now my signal will be superimposed on a high frequency. It means now I will use one car to drive from Delhi to Meerut. So it will be comfortable for me. It means now this low frequency is carried by a car. Okay. So this is the process of frequency translation, or in some time this frequency translation is called modulation. Okay. So these are the 4 basic points where we required frequency modulation. So how this frequency modulation can be done, right? So if I am considering a signal, signal that is AM cos omega mt, one basic signal, or I can say this is your message signal which you want to transmit, or which you want to, or in which you frequency translation method you want to use. Okay. So this frequency translation method, it means we are multiplying 2 signals to get a higher frequency signals, right? So here I am using one message signal whose amplitude is AM cos, AM is the amplitude and the signal is AM cos omega mt. It can be further written as AM cos 2 pi f mt, because of omega is equal to 2 pi f. So this cos of, this cos of theta can be written as e की power theta plus e की power minus theta upon 2. So this formula I will use here, right? So I will one j is also there, right? So this formula I will use to convert this cos 2 pi fmt. So I can write cos 2 pi fmt, it means I can write in place of this e की power j omega mt plus e की power minus j omega mt divided by 2, right? So this is the conversion of your cos signal into exponential form. So am by 2 e की power j omega mt plus e की power minus j omega mt, right? So in terms of, in place of omega, I can write 2 pi f. So am by 2 e की power j 2 pi fmt plus e की power minus j 2 pi fmt. So this is my signal which I have converted into the form of exponential. Now I will use a different signal that is called auxiliary signal, or I can say this is the carrier signal. And always remember, the frequency of carrier signal is greater than FM, message signal. So FC is always greater than FM. Then only you will use the modulation, right? If you are transmitting on the same frequency, then there is no need of modulation, because we want to transmit our low frequency signal at the high frequency. That's why frequency translation is required. So again, the signal is same, AC cos omega CT, but the difference is that omega C. Omega C is the high frequency component, so I will write it AC cos 2 pi FCT. Again, this cos theta can be converted into exponential form by using AC by 2 e की power j omega CT plus e की power minus j omega CT. Omega can be replaced with e की power j 2 pi FCT, e की power minus j 2 pi FCT, right? Now I will multiply these two signals. It means Vm and Vc both are multiplied. So here I have written Vmt into Vct. If I will multiply, so I can write Am AC cos omega mt cos omega Ct. I have multiplied both the signals. So if I am multiplying these two signals, so I will use a trigonometric identity. So what is the trigonometric identity here? I can use 2 of cos A cos B. So what is this? It comes out to be cos of A plus B plus cos of A minus B. Okay. So this identity I have used. For this I require 2. So I will multiply and divide with 2. So multiply and divide. So I can write 2 here and 2 here. So it comes out to be same, twice of cos A cos B, and this is your AM AC by 2. Okay, AM AC by 2 cos of A plus B omega C plus omega M plus omega C minus omega M, right? So again, this can be converted into the form of exponential form. So exponential form, see here AM by 2, so here AM AC by 4. Okay, e की power j omega c plus omega mt plus e की power minus j omega c plus omega mt. So this two terms are for your first. For this term, e की power minus j omega c minus omega mt plus e की power minus j omega c minus omega mt. So these two terms are for second part. It means, see what will happen. I have a signal at a frequency of omega m. I will multiply this signal with the frequency of omega c. Now I received a signal which is a combination of omega c plus omega m and omega c minus omega m. It means one part is above your carrier frequency and one part is below your carrier frequency. Will depends on the frequency of your message signal. Then how it can be represented? See here, this is the amplitude spectral of your message signal. Okay, message signal is having an amplitude of AM by 2 when it is written in terms of spectral component, or you can say frequency domain. I am writing it as frequency domain, so the amplitude will be AM by 2 and signal lies at a frequency of FM. left hand side of the 0 and the right hand side of the 0 is the replica. Okay, so your signal frequency is FM. So at frequency of FM, the signal is AM by 2. Okay, so this is your amplitude of spectral component, or you can say that is your message signal. After that, frequency translation is done. At frequency translation, what will happen? Amplitude of your signal is AM AC by 4, right? And we are getting a signal at two frequency. One frequency is FC plus FM and another is FC minus FM. And FC is the center point, the reference point. Left hand side and right hand side are the replica. So it is drawn on both the sides. So see here, this is your one frequency component at FM. When frequency translation is done, we are getting two frequency component. One is FC plus FM. This is the reference of FC, and another is FC minus. Always remember, when you are drawing this spectral component, this is the 0 scale, is same for both the your spectral. FM is always less than FC. This is the FC. In your frequency scale, always write FM less than FC. Okay, so if you write FM here, so FC should be at this point. So if the extent from the previous logic for message signal, which consists of a multiple sinusoidal signal, right? So in the last case, I have drawn your spectral diagram for a single frequency. Now if you are having a signal which is more than one frequency component, so I can say it is a multiple sinusoidal signal. So again, the signal will be converted into frequency domain. Frequency domain can be done by the Fourier transform. So see, this is your message signal, see FM, okay, and you are having 1, 2, 3, 4 frequencies are present in your message. So this is the frequency diagram or spectral of your message signal. Now when I am doing the frequency translation, so these 4 frequency components are now transferring from FM to FC plus FM. So see here, this is your reference point of FC. So FC plus FM 4 component and FC minus FM again the 4 component. So original signal consisting of 4 sinusoidal of different frequencies is translated through multiplication and become a signal containing 8 frequencies symmetrically arranged about FC. Clear? So 4 component is converted into 8 component, 1 component is converted into 2 component, or I can say if your final frequency translated component is twice of the message frequency component, right? So I can write frequency translated components is equal to twice of message frequency component, right? So now I have converted my signal into the frequency translation. So first modulation is the amplitude modulation, and the amplitude modulation first one is the single tone AM. So here I will teach you what is amplitude modulation, and in the amplitude modulation I will consider single tone. It means, what is the meaning of single tone? It means message is having single frequency. Right? Message is having only single frequency component. So again we will do the mathematical analysis how we are getting the single tone AM. So if a message signal contain only single frequency component, then it is called a single tone AM, right? So this is your expression for amplitude modulation, where AC plus 1 plus KAMT cos 2 pi FCT, right? So Ka is the sensitivity of the modulator, it is written here. Let your message signal, I am taking one message signal is equal to AM cos 2 pi FMT. Now put the value of MT in your modulated expression. S of AM is equal to AC 1 plus KA. In place of MT, I have written AM cos 2 pi FMT into cos 2 pi FCT, right? Now KA AM, that is equal to M, and this M is nothing, that is the modulation index of AM, right? So modulation index of AM is basically the depth of the modulation, how your modulation is taking place, and what is the depth of your modulation is find out through the value of M. If your M is multiplied with the percentage, that is 100%, it is called percentage of modulation or depth of the modulation. So M is having three cases when your M is equal to 1, greater than 1 and less than 1. If your M is 1, it means this is critical modulation. If your M is less than 1, it is called under modulation, and if it is M is greater than 1, it is called over modulation. In our system, we require these two modulation. If we use the third type of modulation, then it will be very difficult at the receiver end to recover the signal, because at the M is greater than 1, what will happen? Your phase translation will be placed, and because of the phase translation, it is difficult to recover the signal at the receiver end, right? So what is the meaning of this under modulation, critical modulation and over modulation? See here, if I will use, I will draw what is the modulation, what is AM. See here, if I am having one message signal, this is your message time T and this is your amplitude. Okay. I will write AM. Message, I am using one of the carrier signal. Carrier signal is higher frequency than your message signal, so it is a high frequency signal time T. This is time T and this is AC, right? So in amplitude modulation, what will happen? This signal is superimposed on the carrier signal. So using envelope detector, if I am using, so same waveform I will draw here and here, and in between is their carrier. Right? This is your modulated waveform. Or I can write it is AM. Okay. So how M can be calculated and what is the value of M? So if I mark, this is V max and this is V min, right? V max and V min. Then your M can be calculated V max plus V min divided by okay. So this is minus and this is plus. If I consider that this is the 5 volt, okay, if I consider this is your 5 volt V max and V minimum is the 2 volt, so what will be the value of M? So M will be 5 minus 2, 5 plus 2, that is 3 by 7, less than 1. So less than 1 is under modulation. Okay. So this is your less than 1, and this M depends on these two factors Ka into Am. Here Am is the amplitude of your message signal, but Ka is the sensitivity of the modulator, which type of modulator you are using and what is the sensitivity of that modulator. Okay, so this is the under modulation. So what is the critical modulation? I will explain first the critical modulation. So see here, I will again draw AMEC. So this is your message signal, this is the carrier signal, right? I will draw one signal like this and another signal I will draw. See how I am drawing the signal. Okay, so time axis T, this is the time axis and this is your message signal AM. Again time T, this is your AC, this is your AM and AM, and Vmin. Again this is Vmax and this is Vmin, right? See here, this is Vmin. So what is the value of Vmax, Vmin? If I am writing, if I consider Vmax is 5, now Vmin is 0. Here Vmax is 5 and Vmin is minus 2 now. Okay, so if we go to the calculate value of M, so value of M can be calculated for this case. M is equal to 5 minus 0, 5 plus 0. So it comes out to be 1. It is a case of critical modulation. Clear? In this last case, M is equal to 5 minus minus 2 and 5 minus 2. So it comes out to be 7 by 3 greater than 1. So what will happen? See here. Here your carrier signal is in the same phase at which it is going. But in this case, your signal is positive, then it comes out to be negative. Here your phase reversal will be take place. That's why this type of modulation is not required. So this is the case of how modulation index is calculated. So we were on the topic of single tone AM. So if I will erase this thing, so that I can explain what is the single tone AM. Okay, so see, this is your amplitude modulated waveform. AC 1 plus M cos 2 pi FMT cos 2 pi FCT. So M is replaced with the message signal. So I can write open the bracket AC cos 2 pi FCT, AC M cos 2 pi FMT cos 2 pi FCT. Again, so we will use the identity of the cos. So this signal remains same, AC cos 2 pi FCT. Here I can write AC M by 2 cos A plus B plus cos A minus B, right? So I can write cos 2 pi FC minus FM AM ACM by 2 cos 2 pi FC plus FM by 2. So I will get three frequency component. Okay, so 1, 2 and 3. So this is the carrier which is working at a single frequency of FC. This is your lower sideband. Why it is called lower sideband? Because the frequency is less than the carrier frequency, and it is FC plus FM. This is upper sideband because frequency is more than FC. Okay, so this is all about your single tone AM. If I will draw your spectral, so if it is 0 and this is FC, so I will get two component. One is the upper sideband, this is your FC plus FM, and another is the lower sideband, FC minus FM. Right. So thank you very much. This is all about your single tone AM. In the next lecture, we will study about another type of modulation.